Okay, greetings, one and all, and welcome to this chemistry lesson. The topic for this lesson is separating mixtures. Again, separating mixtures. And so let's begin. So, processes to separate mixtures. Now, when some materials are mixed together, it is possible to separate the mixture and get the original materials back. So, notice that point. We are going to separate these mixtures so that we could be able to, watch this now, we'll be able to get the original materials back again. And so that's the key thing. We're looking at separating mixtures. Now, what are the processes, right? What are the processes to separate these mixtures, right? So there are several ways to separate mixtures. Now, the best process to use depends on the type of mixture you are separating. So in order to do that, you need some discernment, you need some understanding, all right, of certain things so that you can be able to choose the best one. So don't just say, oh, we're going to use evaporation and condensation all the time, or we're going to use magnetism all the time, or we're going to use filtering all the time. No, you use the different processes based on the mixture that is in front of you. So if a mixture of salt and water is in front of you, you're going to treat that differently than if it was a mixture of oil and water in front of you. And so there are several different ways of separating mixtures, but the best process to use depends on the type of mixture that you're separating. So what are some ways of separating mixtures? Well, number one is evaporation and condensation. Number two is magnetism. Number three is filtering. Number four is sieving. And number five is decanting. And again, these processes are going to help us to get what the original materials back again. And we're going to have to use some discernment in understanding which one is best to use at that particular time. Okay, so let's begin with evaporation and condensation. Okay, so this process is best used to separate solutions. That's very important. That's a very important idea. We use evaporation and condensation when we're separating solutions, all right? And when you think about solutions, right? Solutions, for a solution, you're gonna have a solute, right? A solute, and you're gonna have a solvent. Okay, so you're gonna have a solute and you're gonna have a solvent. Okay, so the solute is usually solid, right? Like a solid particle, and it is the thing that is being dissolved, right? So in the case of a solution of, say, let's say sugar and water, right? So you have water and you have these sugar particles, right? Okay. So the solute is going to be these sugar particles. These are going to be the things that is going to be dissolved, right? And the solvent, or that is usually the liquid part, okay? The solvent is the thing, in this case, it'll be the water. So in this case, in this example, the solute is going to be the sugar. And in this case, the solvent is going to be the water, all right? So that's a solution. A solution is made up of a solute and a solvent. The solute is the thing that is being dissolved, and the solvent is the thing that does the dissolving. Okay. So when we are considering evaporation and condensation, right? We'll be using them when we're considering solutions. What are solutions? Mixtures in which a solid, that's a solvent, has dissolved in a liquid. Okay. All right. Next up. So as the solid has dissolved in the liquid, filtering would not separate the two materials. That's a very important idea. If we have, say, for example, sugar and water or salt and water, and you try to filter, right? So, you have filtering, okay? With filtering, we have something like this, all right? And we pour in the solution inside there and you try to filter it, right? You can't filter salt and water, and you can't filter um, sugar and water because it's dissolved into it. It's as if it's a part of it, right? It's as if they are one, right? Think, for example, like Kool-Aid right? When you have that dye placed inside the water, right? You can't really separate that um, by filtering. You must use evaporation and condensation. So let's dive into it some more. Okay. So as the solid is dissolved in a liquid, filtering would not separate the two materials. The solid particles would go through the filter paper along with the liquid, and that's true. If we because it's dissolved, because the sugar is dissolved into the water, if you try to filter it and you pour it through the filter paper, well, the filter paper, what it does is that it holds the solid part and it lets the liquid part go through. But in this case, the liquid and the solid are one. It's already dissolved into it. The particles are dissolved into the water, so it won't work. Okay, so what do we do when the solution is when the solution is evaporated, either through boiling or being left in a warm place? The liquid will turn into gas and leave the solid behind. Okay, and so what happens is, let's say for example, you have something like sugar and water or salt and water, and let's say you would boil it, right? If you boil it and you let all of the liquid turn into gas, that's evaporation, when liquid turns into gas, and then what's left behind is the solid part, and so you separated the two. Okay, now when you already allow the liquid to turn into gas, you want to find a way to trap that, right, to get it back again. Okay, so means once we get that gas and we condense it, and so that means that we apply or we put it in a cool place so that it turns back into liquid. So if the gas is then condensed on a cool surface, the liquid will be recovered and collected too. Examples of mixtures to separate with this process is salt and water or sugar and water. So if we have salt and water or sugar and water, evaporation and condensation is the way to go. And so that's very important. Remember we said in the previous slide, we said that, hey, the best process depends on the type of mixture you're separating. So if we have something like salt and water, if we have something like sugar and water, we want to use evaporation and condensation. Moving right along. Magnetism. Magnetism. So with magnetism, obviously we're gonna use a magnet, all right? And we're gonna take advantage of the attraction property of that magnet, all right? So we use this process to separate magnetic materials from non-magnetic materials. So if we have a mixture of stuff that is magnetic and stuff that is not magnetic, we would use a magnet to pull out the parts that are attracted to the magnet. And that's a very good idea. So a magnet is used to attract any magnetic materials and remove them from the mixture. You could separate a mixture of copper nails and iron nails using this process. And so the process is very it's very intuitive and it's very simple. So if we have, say, uh, a flat piece of surface, and we have two different things. We have something that is magnetic, and we're going to use that in black, right? That's the magnetic part, stuff that is magnetic. And then we're going to use the the blue to demonstrate stuff that are not magnetic. Okay, so the blue represents stuff that are not magnetic. And so you can imagine that when I apply this magnet to um, to this mixture, what's going to happen is all of the all of the pieces that are magnetic are going to be attracted. So this one is going to be attracted to the magnet. This is going to be attracted to the magnet. This is going to be attracted to the magnet. This is going to be attracted to the magnet. This is going to be attracted to the magnet. And so what is going to happen? Because those parts that are attracted to the magnet are taken away with the magnet, all I would have left is the blue pieces or the non-magnetic pieces. And so that's the idea. Moving right along, now we have filtering. Now we said that filtering would not work for stuff that is a solution, stuff in which the substances are dissolved in the liquid, right? But filtering could be used for when we have an insoluble solid and a liquid. So what that means is that you have something like, say for example, let's say you have sand. So you have the water again, but let's say this is sand, right? So you have sand and water. If you have sand and water, so if you have sand and water, the sand is not going to be dissolved into that water, right? And so if you use the process of filtration, what's going to happen is as you pour this solution, not solution, but as you pour this mixture into this um, entity here, as it pours in, the hard part or the insoluble part, like the dirt or the sand, is going to get stuck in the filter paper, and the liquid is going to go, to the bottom. Right? This is the perfect example of a true separating mixture. You could actually see the separation. The solid parts stays into the filter paper, and the liquid part comes down at the bottom. So stuff like sand and water is gonna work here. Okay, so what does it say? They tell us that this process should be used to separate a mixture of an insoluble solid like sand and dirt, something that is a rock, okay, and a liquid. A funnel is lined with filter paper and placed over a beaker. The mixture is poured slowly into the filter paper. Now, insoluble solids will not have dissolved in the liquid. We said that it does not dissolve. The solid particles will not be able to get through the tiny holes in the filter paper and will be caught in it. The liquid particles will go through the filter paper into the beaker below. This process could be used to separate a mixture of sand and water. All right, next up is sieving. So we use this process to separate a mixture of different sizes of of different sized solids. So what do we mean? So let's say we have the mixture. So let's say for example we have a mixture of let's say we have rice and pasta, right? Um, so they're telling us that mixtures you could separate using this process include raisins and flour or rice and pasta. All right, and that makes sense. If we have raisins and flour or rice and pasta, we can separate it using sieving, and it may make sense if you have the raisins and you have the flour and you would shake this. I don't know if any of you are familiar with this type of entity, but you shake it and the flour would automatically go through and the raisins would stay, because the raisins of course cannot fit into these small tiny pieces. All right, so the mixture is poured into a sieve and held over a bowl. The smaller particles will get through into the bowl and the larger particles will be caught in the sieve. All right, so if you have, let's say for example, you have a mixture of say raisins and flour, all right, so they are two liquids, right? So raisins are usually purple. So let's say we have raisins, right? So we have these, let's make it big and pronounced. We have these raisins here, and we have raisins and flour. And if we pour the mixture of raisins and flour into the sieve, what's going to happen is the flour will go through directly, but the raisins will be caught, right? So they have, and then if we have a bowl, right, the flour will be in here, all right, and then the raisins would stay inside this entity here. Okay, so like they say, the larger particles will be caught in the sieve, so the raisins will be caught in the sieve, but the smaller particles like the flour will it will go into the bowl. So that's sieving. And last but not least, we have decanting. So now this process can be used to separate two liquids. Right? So we just talked about separating two different size solids. But what if we have two liquids? Now, if you have two liquids with different densities, okay, then we'd use decanting. Okay. The mixture the mixture of liquids is left to settle. So the two liquids are visible as two different layers. Okay. And so what happens is, let's say for example, you have oil and water and you let it sit over time, and then it'll separate. Okay, they'll form different layers. Okay, so the less dense liquid will be at the top layer. So oil is less dense than water, and this can be decanted or slowly poured off. So since the oil is going to be on top, once it's settled properly and they are properly they are properly once they're settled properly, and you could clearly see the visible layers, you can pour off the oil on top, right? Pour it off slowly, and that way you can separate the oil from the water. This process could be used to separate a mixture of oil and water. So decanting it's going to use to separate a mixture of oil and water. And so that's all of our separating techniques that we talked about. We talked about evaporation and condensation, magnetism, filtering, sieving, and decanting. For evaporation and condensation, that you could use those for stuff like salts and water, stuff like sugar and water, where we have a solution and the particles are dissolved into the liquid. So we use evaporation and condensation. For magnetism, we're going to use magnetism for stuff where we have magnetic particles and then we have non-magnetic particles, and we're going to use the magnet to attract those magnetic pieces. For filtering, we're going to use that for when we have liquid and we have insoluble solids. And so we have some like sand and water, rock and water, dirt and water. Make sure the dirt is, big chunks of dirt and not the dirt that could easily pass through the filtering paper. Once you pour it through the funnel, what has the filtering paper inside, what's going to happen is the the solids are going to be trapped in the filtering paper and the liquid is going to allow to pass through. Then sieving is going to be used when you have different size solids. So like your raisin and flour, the flour is going to go straight through the the sieve, but the raisins are going to be caught in there. And then decanting is going to be used for separating two liquids that have different densities. The one that has a less density is gonna be on top. The one that has a greater density is gonna be at the bottom. And you can easily pour off the one that has a less density. Pour it off or decant it, slowly pour it off. Okay? And so those are the processes of separating mixtures. Okay, so there is an exercise that I want you to do. I want you to consider this exercise. So it says separating mixtures, draw a line from the process to its correct description. Um, so we're gonna basically match. Okay. So answer these questions for me. And also it says right in the process used to separate each mixture. So salt and water, sugar and water, rice and pasta shapes, sand and water, flour and rice, paper clips and sawdust. What processes we're gonna be using to what separating technique will be you use to separate these. Okay. So two things I want you to do. I want you to write the notes based on this lesson, and I want you to answer these questions based off of the lesson. Now, the next video that I will send you will be the correct answer to these questions, but I want to see your response first. So send me that and we'll be good to go. Thank you so much for watching, and I'll see you in another video.